Okay, so for example 4, so we have the region, again, rectangles perpendicular to the y-axis. When entering graphs in the form of x of y, you have to enter y's as x's in the calculator. So again, you're looking at the region that's in the first quadrant only. So make sure you always know, sometimes it's very specific, bounded by the graphs y equals square of x and y equals 1/3 of x. And again, the region R is the basis. For this solid, the cross sections are perpendicular to the y-axis. So again, perpendicular to the y-axis means it's going to be a dy problem. Now here's where you've got rectangles, and remember, I told you if it's a rectangle, they have to give you the relationship between the height and the base, whose height is 5 times the length of the base. And again, the base is the base of the solid. So we know the area of a rectangle is base times height. So they're telling us that the height is 5 times the length of the base. So the height is equal to 5 times b. So my area formula then is going to be the base times 5b, or 5b squared. And again, remember the base is your s. So this is going to be 5s squared. So remember, since it's a dy, s is going to be equal to right minus left. So we have to now take a look at the picture. So when I go to sketch the graph, I know 1/3 x is just a line passing through the origin with a slope of 1/3. Square root of x, I know is my square root function. I know square root of 1 is 1. Square root of 4 is 2. So again, trying to calculate this region. Now remember, my cross sections are perpendicular to the x-axis. So my triangles, or rectangles, excuse me, look like this. It's hard to draw something three-dimensional, two-dimension. So then the function that's on the right is going to be your line minus your square root function. But now remember, what you have to do is, because it's a dy, you have to solve for x. So I have my function y is equal to 1/3 x. So then x is going to be equal to 3y. Y is equal to the square root of x, so then y squared is equal to x. So then for s, the function that's going to be on the right, which is my line, is going to be 3y, minus the function that's on the left is going to be my y squared. So then to find my bounds, if this was a no calculator question, the way you would find your bounds is you would take your, we know that they're intersecting at 0, 0, so you can take your 3y minus y squared and set it equal to 0. So y, 3 minus y equals 0, so y is equal to 0 and 3. So then this is intersecting at 0, this is going to be something comma 3. So then when I go ahead and calculate this volume, again, I know that my formula is going to be 5s squared. So 5 times the antiderivative from 0 to 3. Again, remember, s is going to be your 3y minus y squared dy. And again, if I use my calculator, again, I can go ahead. Now remember, this is where I mentioned on your calculator, you can't change these x's to y's on the y1, y2. So just type in the x for the y. So 3x minus x squared. So then my volume is going to be 5 times your antiderivative, going from 0 to 3. Open up a set of parentheses. Remember, 3y I have located under, everything's located under y1. So I can just then type in y1 squared. So I end up with my volume to be about 40.5. So here's a right isosceles triangle perpendicular to the y-axis, and this is a calculator question. So the region is bounded by the x-axis, and the graph's 2 minus x to the third and tangent of x. The basis for this solid, the cross-sections are perpendicular to the y-axis. So right away that tells me that it's a dy problem. And they're telling me that it's a right isosceles triangle with the base as the hypotenuse. So then the area formula for the cross-sections, remember, is going to be my s squared over 4. So because it's a dy problem, remember, s is going to be equal to your right minus left. So then we can take a look and get a graph to see which function's on the right, which one's on the left. So under y1, I'll type in my 2 minus x to the third. And then under y2, it's going to be tangent of x. Now because it's a tangent graph, remember we know that we have vertical asymptotes happening at pi over 2. So I'm going to change that x max to be pi over 2. And again, I'm going to bold. And let's see what this is going to look like. So remember, you're bounding it between it's in the first quadrant. So actually I could change my window, change that x min to 0. So then my graph sort of looks like this. So again, I'm going to calculate the volume of this region right in here. So again, I have to find this point of intersection. So I'll go under second trace, intersect. So I end up with 0.902, 155, and 1.2657. Again, right minus left. So if you look on the graph, you can see that the function that's on the right is going to be the inverse tangent, and then the left. Okay, because we're going like this. So then, remember, because these are dy problems, you've got to solve each for x. So again, when you look at y is equal to tangent of x, you have to do your inverse tangent. So x is going to be equal to your inverse tangent of y. When you have 2 minus x to the third, so y is equal to 2 minus x to the third, y minus 2 is equal to negative x to the third. So negative y plus 2 is equal to x to the third. So it's the cube root of negative y plus 2 equals x. So then when I go to find my volume, again, I can pull out the 1/4. Again, it's a dy, so your bounds are in terms of 0, so 0 to 1.2657. And again, it's going to be s squared, so it's going to be your inverse tangent of y minus the cube root of negative y plus 2. And all of that is going to be squared, dy. So then on your calculator, again, you're going to have to change your functions under y1 and y2. So I have to have my inverse tangent of x. Like I said, you can't change that x to a y, but this is just calculation purposes only. So then math, cube root, it's going to be negative x plus 2. So then on my home screen, I have 1/4 times your integral, 0 to 1.2657. And again, I've got my inverse tangent under y1 and my cube root under y2. So it's going to be parentheses y1 minus y2 squared. So we end up with 0.147. So then the last example is the equilateral triangle perpendicular to the y-axis. So we have the volume whose base is enclosed by the circle, x squared plus y squared equals 4, whose cross sections are perpendicular to the y-axis. Again, this is going to be a dy. And they're equilateral triangles. So remember the area formula for equilateral triangles are square root of 3 over 4 times s squared. Now the thing you have to be careful about with circles, especially because it's a dy, you have to take your equation, and when you graph it, we know that the center is at 0, 0, radius is 2, so being perpendicular to the y-axis, I know that s is going to be equal to right minus left. So because it's a dy, I have to solve for x. So then x squared is going to be equal to 4 minus y squared. X, when you go to do the square root, remember, you have to remember to do your plus or minus. 4 minus y squared. So the function that's on the right, remember, you have the positive 4 minus y squared, which is the right-hand side. And then you have the other side of the graph, which is your negative square root of 4 minus y squared. So when you set your s up, it's going to be your right minus left. So the function that's on the right is your positive square root of 4 minus y squared, minus your functions on the left, which is negative square root of 4 minus y squared. So s is actually going to be equal to 2 times the square root of 4 minus y squared. So you have to be careful with the circles. So now remember, this is your s. You have to square s. So when you set up your integral, the volume's equal to, I can pull out that constant square root of 3 or 4. You cannot pull out the 2 until after you square it, because this is going to be your antiderivative again. Your bounds are going to go from negative 2 to positive 2. Remember, those are your y values, because it's a dy. So it's going to be 2 times the square root of 4 minus y squared squared dy. Now, if this was not a calculator question, what you could do at this point, when you square the 2, that gives you a 4. You can yank out the 4 at that point. That would leave you the square root of 3 times negative 2 to 2 of the square root of 4 minus y squared squared dy. So, but since this is a calculator question, I'm just going to go to my y equals, type in the 2 times the square root of 4 minus y squared, which is just going to be an x squared. So then I'm going to have square root of 3 divided by 4 times the antiderivative, going from negative 2 to 2 of y1 squared so 18.475. That's volume by cross sections.